In this e-content, we are going to see the different types of fluids and the different types of flows. So a fluid is nothing but any material which flows is called as a fluid. For example, water flows, honey flows, kerosene, they are all examples for a fluid. So fluid is classified into a compressible fluid and an incompressible fluid, and based on certain properties it is also classified as viscous fluid and inviscid fluid. So we'll see what do we mean by a compressible fluid. Before that, pressure is nothing but force acting on an unit area, and density is nothing but mass per unit volume. So if the changes in pressure brings changes in the density of the fluid, then that fluid is said to be a compressible fluid. So example for compressible fluid are gases, because the intermolecular attraction between the gases is very much less. And also, if we take a cylinder, the gas will be occupied by the entire portion of the cylinder. That is, for a fixed volume, the entire portion of the container will be occupied by the compressible fluids. But this will not take place in the case of incompressible fluids. So we'll see what we mean by an incompressible fluid. So if the changes in pressure do not change the density of the fluid, then it is said to be an incompressible fluid. So liquids are incompressible fluids. So with a fixed volume, incompressible fluids do not occupy the entire area of the container. They only take the fixed volume. Example, water. And the intermolecular attraction between the liquids is almost in a moderate stage. But as case of solids, the intermolecular attraction will be very large. Next, we'll see what do we mean by forces acting on a fluid body. So force is something which produces a change in a body. For example, pushing an object or pulling something is also called as a force when we are applying an external effect on any object. So we will consider a small portion of the fluid P and it is surrounded by a surface. And I take a very small elementary area of the surface which is given by delta S. Then the surface force acts in two directions. One along the normal to the surface and the other along the tangential direction. So two types of forces act on the fluid body or on any body, and that is known as body force and surface force. So body force is a force which can be applied externally on any fluid or any object, and the influence of the fluid will be felt throughout the body. For example, we can consider electromagnetic force. So when we are placing a steel object on a magnet, we can see that the steel object entirely gets a magnetic force. But a surface force is a force which can be applied only on the surface, and its influence will not be felt throughout the body. For this, we are considering an example as pressure. So when we boil water, we can see water droplets on the surface of the container. That is nothing but it is the pressure which is observed only on the walls of the container. That is the surface of the container. Stress is nothing but force acting on an unit area. So it comprises of two parts, tangential stress and normal stress. So tangential stress is the tangent force acting on a unit area, and normal stress is nothing but normal force acting on a unit area. Next, we will see an important property called viscosity. So in the case of honey, castor oil, we do not see a rapid flow of the fluid. So the flow is obstructed by certain fluid particles which have got some internal friction. So viscosity is a property which arises in the fluid particles due to friction, and it does not allow the fluid to move faster. So, this internal resistance is quantified by a property or measured by a property called viscosity. So, a fluid which exerts both tangential stress as well as normal stress is said to be a viscous fluid or a real fluid. Example, honey and castor oil. So, a fluid which does not exert tangential stress is said to be an inviscid fluid or an ideal fluid. Example. Next we'll see what do we mean by deformation. So if there is a change in the shape and size of an object when we are applying a force, that property is called as deformation. So when a fluid is flowing, we can see that the deformation, the change in the shape and size increases continuously without limit if any force is applied on the liquid. For example, if you are having a certain amount of water on the table and if you give a certain jerk to the table, we can see that the water flows. No disturbance is given, we can see that water is flowing continuously. So there are various types of flows such as laminar flow, turbulent flow, steady flow, unsteady flow, irrotational flow, rotational flow, uniform flow, non-uniform flow, and barotropic flow. So we'll see what do we mean by a laminar flow. So in a laminar flow, the fluid particle describes a definite shape and the curves traced out by the and a definite curve is traced out by the fluid particles. The fluid particles travel parallel to one another and they do not intersect with each other. Say for example, the flow of blood through small veins. So in the first diagram, we can see that the flow of blood, the particles the layers of the blood do not interact with each other. In the case of a turbulent flow, the fluid particles will not trace a definite curve and the curves will intersect with each other. So in the first diagram, we can see that the blood flow is being entangled in the case of a turbulent flow. So when smoke is arising from a chimney, initially we can see a laminar flow. It will be in the form of a straight line, and as the smoke goes up and up, we can see the entanglement of the smoke. It is not in a definite direction, so it is spread out throughout. So this is the example for turbulent flow. Next we'll see what do we mean by a steady flow and an unsteady flow. So a fluid always possesses certain properties such as pressure, density, volume, velocity, etc. So when a flow has all these properties and if these properties are independent of time, then the flow is said to be a steady flow. Example, a reservoir. So we can see that water is traveling with an equal velocity from the beginning till the end. So there is no curves, ups and downs in the velocity. But in the case of an unsteady flow, the properties such as pressure, density, volume, velocity, etc. they are dependent on time. So the flow varies with each and every instant of time. So we are having an unsteady flow. For example, we can consider tidal waves or flood waves. Next, we'll see what do we mean about a uniform flow and a non-uniform flow. So, in a uniform flow, the fluid particles will possess equal velocities when the fluid passes through each section of the channel. But in the case of non-uniform flow, the fluid particles will possess different velocities at each section of the channel or pipe. Next, we'll see what do we mean about a rotational flow and an irrotational flow. So, In a rotational flow, we can see that the fluid particles rotate about their own axis. So thereby we can see a rotatory motion in the first diagram. But as well as in the case of an irrotational flow, the fluid particles do not rotate about their own axis. So in this case, we will get an irrotational flow. So these are the few concepts about fluids and flows. Thank you.